Hello, I am Shane Brinkman-Davies-Delamore, and this is Code and Optimism, a show where we explore how to solve problems faster with software. Today we embark on a new broad range of topics. The topic today is modules, and we're going to be talking about this for several episodes. So first episode here is kind of a survey episode. So let's take a look at the highest level here. So the first question is, why do modules matter? And the key thing here is it's all about complexity. Complexity grows exponentially with code size. It's a major problem. In fact, it is the single biggest reason why projects will fail. It is the single biggest reason why you will become slower and slower over time as your code grows. Complexity grows exponentially with code size. And that's because if you don't modularize, all your code talks to each other. And the more code you have, the more cross connections you have in your code. It's basically the network effect. On the other hand, good modular design actually can not only help you combat this, but it can give you superpowers. It can give you complexity fighting superpowers in the sense that you can actually accelerate your project as it gets bigger. Your project can get faster as it gets bigger if you do good modularization. That's why modularization matters. It matters a ton. So let's get into it a bit more. So next, I just want to sort of set the stage. What is a module? And I'm going to do a fairly basic definition here. We talked in the previous episode on dry, I'll have a link to that down below, that the result of drying up code, which is say you've got repetition, you have the same bit of code twice, which might mean you're going to do step A, and then you're going to later do step A again. And you dry that up and you create a reusable thing that now you just call it for those two different times rather than having the code be duplicated. And you have now created an abstraction. And an abstraction is always simply the drying up of repetition. So it's taking multiple concrete things and making them into one abstract thing. And the result is a reusable component. And that, my friends, is what a module is. Now, we want to really emphasize component sometimes means something specific in our world. Here, I mean just a reusable thingy. Anything that is reusable in software is a module. So now, we're going to jump into a little demonstration of the module hierarchy. So here we are at the bottom of the hierarchy. Our language provides us with various atomic elements we can start constructing instructions for the computer with. At the simplest, it's like the mathematical operators, plus and minus, and times and divide. And then it is the comparators, less than, equal to, etc. And then we end up having conditionals like if statements, and you know how all that goes. The first module we start to create, and to be clear, those are modules, but those are modules that the language is providing for us. And generally, unless you're a language designer, you're not writing those modules. The first module you might encounter as a developer using a language is writing a function. So in the example we just talked about with dry, you dried something up. It might be a statement or an expression that you had repeated. The most likely what you're going to do is you're going to bundle that up into a function. And that function now you're going to use twice. Functions are modules. They are generally the first and lowest module, and you're going to have lots of functions. Now, often you get to the point where you've got several functions that are related. And you will bundle those functions together into what we often call in software a module. So there's this discrepancy between I'm having this general concept of modularity, and then we kind of have this specific concept that's usually like languages. And in old languages, generally they're classes is what we talk about. In functional languages, they're probably called modules. It's the same thing. It's a collection of functions around a common topic, usually a common type of data you want to manipulate, but sometimes it's just a common related topic. And when we get to the how to do good modular design, we'll understand which functions should be grouped together to make a good module. So each function's got a bunch of atoms. Each module or class has a bunch of functions. And it is typical for us to put each module into its own file. generally good design. But you have to realize that that file really is a module. Even if you just threw a bunch of functions into a file and you weren't really thinking about it too much, that file is now a module. You have now grouped functions together in some logical way. Or maybe it was not a very logical way. Maybe you made a lib file or a util file. That should be a red flag for this is not good modular design. Files are modules, and they need to also be thought about as good modular design. Next step up, and this is the one that I think gets most overlooked. Directories are modules too. A directory contains files, and those files are modules. So a directory is another step up in your hierarchy of modular design. And I might talk a little bit about this more later, very specifically directories, but one of the most important aspects of modular design is encapsulation, which means that no one using this module should ever reach into the insides of this module. It should always use the API. This I see very often in code get violated with directories. People will include files from other directories and deeply nest into that subdirectory to pull a file 5 levels down, or even just 2 levels down, or 1 level down in a parallel directory. Parallel directories are inviolate. You should never reach inside another directory to pull files out. That is the same thing as reaching inside a class to its private members. Directories are modules. You should use good modular design with directories. Now, typically, the next level up is we've got some cluster of directories of files, and then we might make a package. And I'm just using JavaScript notation here, nomenclature here, but in general, every programming language has these collections of shareable, useful chunks of code, which then are bundled up and put into a shareable library like NPM online on the internet. But even if you're building your own code, I strongly encourage you to be thinking about what packages can I make, because this is another good level of modularity. And this is, I suppose, the other main level that people think about normally as modules. There's the module or class inside your project, and then there's these packages, which we also kind of think of as modules with that phrase. But I emphasize everything I'm showing you here is a module, and everything deserves good modular design. But wait, there's more. Packages often get grouped up into frameworks, and that's a bunch of interrelated packages that work together. Classic example these days in the JavaScript world is React. React is one package, but there's a bunch of packages that come together, and there's frameworks built on frameworks. And this is a good time to mention, as I'm showing you this hierarchy, this is a conceptual hierarchy, but this is not a literal hierarchy of how your code will work, because you might have a function which has subfunctions, and those subfunctions might have subfunctions. So each layer here might have many repetitions at that same level. So you might have a class or a module that is made up of many classes and modules. You might have a directory, of course, has multiple files. You might have a package which has tons of directories. And you might have packages which import other packages, which import other packages. This hierarchy is actually way deeper than I'm even showing here, because there's repetition at each of these levels. But wait, we're not done. From the framework, we go up to your app or service, what you are building as your product that you're putting out in the world. You're making, this is basically, if you're not doing a mono repo, this is the contents of your repo of the thing that you're putting out there. And you might be making, in the typical world I work in, which is what I think a lot of developers do these days, is you're either making an app that's going to get bundled and deployed, or you're making a service which is going to be put in the cloud for being accessible either internally or externally. And then on top of that, you have the product system. So quite often, to actually deliver a product nowadays, you need to have at least a backend service, which is like an API. You might have a website around that, which might be separate. You might have different mobile apps you're deploying to, or other IoT targets. You've got an ecosystem of apps and services. Each one of those is a module within your product's system. And this is a good point to mention. I think this is where we transition from software engineering to systems engineering. And they're definitely related, but systems engineering is kind of different, but it still uses good modular design. That's the fundamental aspect of all of these. The same 5 essential elements of modular design, which we're going to get into, apply at all these levels. But wait, there's more. Now we're up to the company ecosystem, and the classic famous example is Apple's ecosystem. The way of the iPhone and the iPad and Apple Music and iMessage and your watch and your desktop and all of these things work together because they're all modules and they all interact with each other and share information in effective ways that are a designed modular system. And now we'll go just one more level up here. I think we could probably invent even more levels on this tree, up to the internet. The internet is a collection of all of these modules, all of these solopreneurs, open source, websites, companies, company ecosystems. It's a great, delightful mess of beautiful and ugly all together, all these modules out there. Modular design is how we are where we are today. Without modules, we would literally be writing assembly code and not having operating systems. Modulars are our superpower for making bigger things, for standing on the shoulders of giants and really making progress in software. And the key thing is, one, we should be doing a lot more modular design, a lot more modules, a lot more modular design, and we should be doing it a lot better to really get that complexity fighting superpowers. All right, here we are back at the top. So briefly, I'm going to talk about the upcoming episodes. Things I'm going to be touching on that I've identified so far is we've talked about the why, complexity fighting superpowers, but what does it really work out into in terms of concrete benefits of modules? And there's a whole bunch of them. Then we are going to dive into the 5 essential elements of good modular design. And I think it is sort of the abstract description of good modular design, which I think for many people that'll be enough. It's super useful. And I'm probably going to do an episode on each because they are all super important. But then I also want to do a little bit more practical of the how and when to create modules, because I see a lot of otherwise skilled engineers not creating modules in their daily routine. I mean, you might be making functions or classes, like that's fine, I get that. That's probably pretty common, but I think a lot of people don't think about using directories as modules, as I've already mentioned, and even more significantly is people don't think about using their platform's packaging system within a project. I think it is a hugely beneficial thing to start finding chunks of your code and packaging them up into packages. Maybe you make a monorepo, maybe you deploy them otherwise, maybe they're just open source and you open source them and then pull them back in. That is a very critical thing for scaling projects that are getting over 10 to 50,000 lines of code. If you're getting to 10 or 50,000 lines of code in your system, it's time to start thinking about packages. And we're going to go into that more in the future episodes. So to recap today, complexity destroys productivity. And complexity scales exponentially with code size without modular design. If you're not doing good modular design, when you have 1,000 lines of code, let's say that you have 1,000 units of complexity, when you go to 10,000 lines of code, 10 times as big, you are dealing with perhaps 100 times as much complexity. I mean, we could argue about what the scaling factor is, but it definitely is exponential because code references each other. It's a network of cross-references. And the whole practice of good modular design is managing the complexity of all the interconnections and cross-references of your code. And if you do it right, it gives you complexity fighting superpowers. And this is really the key thing that I think people don't realize. If you get really good at modularity, your project will get faster as it gets bigger. Let me say it again. Your project will get faster as it gets bigger. That is not the common wisdom in our industry. And I'll tell you why. It's actually really clear why it will get faster as it gets bigger. Because if you do good modules, you are creating reusable components that give you lift. The reason why we can do all the great stuff we can do today is because we've got cloud services out there. You know what that is? That's a pile of well-designed, reusable modules. That's a huge pile of code out there, folks. That's a monster of pile of code. Your OS is a monstrous pile of code. And all of the libraries in our ecosystem are a massive pile of code. The reason why we're not overwhelmed by that, 100 million, billion lines of code that we are using directly is because it's well modularized. Same thing applies to your project. As you build these modules that are powerful, reusable, they elevate you, your ability to solve the next problem gets faster and the complexity never drags you down. You can get to the point where complexity is basically flatlined with modular design. And if that doesn't get you excited to dive into modular design, I don't know what will. So thank you so much for spending your valuable time with me. I will throw out the question of, have you taken that leap on a project from thinking about something that this should be reusable? Maybe it's something you want to reuse across projects, is often a place I start, and thought about, I should package this up and deploy it onto NPM or whatever your package manager is. If so, I would love to hear your comments about why you did follow through or why you didn't follow through with that insight. And I would also love to hear, what was the insight that made you think you needed to do that? Like, what was the tripping point? Because that's a bit of the how and when we're going to get into in the future. I would like to hear your experience, because I think there's a lot of different triggers about when it makes sense to do it. And I only know the ones I run into. So with that, just remember, all problems are solvable with enough knowledge.